This is a brief presentation about a very specific crop system that is it takes place in the southeast of Spain. This is our production area. Probably many of you knows this place. This is also named as the Sea of Plastic. This is in the West countries that held around 12,000 farmers owning their own greenhouse and making their lives with the production of winter vegetables using the light and the heat of the sun. Well, as you can imagine, this system is not very well balanced, and the crops are threatened by different pests, not only insects and mites, but also uh, many different pathogens. And this makes this is a risk for the profitability of the production. And you can see in this picture, in this figure, that there is a high part of the incomes of the cost of the production that goes to prevent and protect the crop against the pests that are normally coexisting at the same time in the crop. In fact, for organic growers, this perception of the risk is higher. And I like to use this graph where we can see the decrease in some years of the use of biological control by growers and the increase of the organic horticulture in the place. This is this can be do be big because of the use of sulfur and copper that are not specifically target products and are not compatible with other beneficials. Uh, in fact, the presence of copper in soils is getting higher. These are results from a old trial or all analysis in 2002, where the average content of copper inside the soils of the greenhouses was not very high, but there were some greenhouses in the survey that showed high levels of copper content. This was 18 years ago, and they were conventional farmers. I am sure that nowadays, that today, the content of copper in soil of organic growers in our place is much more higher than this in average. And this is the reason why we are here in Organic Plus in the work package 3 that is led with for Nikos. We have worked in the different tasks of this work package. We produced also the fact sheets, as Ulrich said before in Spanish. And we decided to look for solutions, alternatives to copper that really available, commercially available for growers. So that's why we made interviews and surveys to experts and farmers owning greenhouses, asking them for which alternatives they were using right now. We find different types of alternatives, and we decided to focus on natural biocides or biostatical products. There is experience in the field. This is experience from the experts and the farmers, and together with them, we decided to work with 12 alternative products. And as a model, we decided to use Botrytis cinerea. That is an endemic disease in the winter greenhouses, and we started looking for fresh Botrytis isolates, and we tested the 12 products, alternatives to copper, with the minimum and the maximum dose recommended by the manufacturers. And we tested all of them in comparison with copper oxychloride at 50% of content in copper. That is a very typical product used here in the greenhouses. The results of this in vitro test for those products considered mineral fertilizer with low content of copper or without content of copper was that gluconic copper with only 5% content of copper was better than the copper oxychloride at 50%. This result was really amazing for us, because the advisor said, okay, this product is good, but we couldn't imagine that, in fact, under in vitro conditions, the results were so nice. Concerning the basic substances that we tested in the in vitro test, and none of them was better than copper oxychloride. This doesn't mean that they are not useful, because some of them can elicit the defense response in plants. However, in vitro tests, when they were confronted with the botrytis colonies, there was not a good effect, better than copper oxide. Among the plant extract fertilizers tested, we found that two different cinnamon extracts, two different products with different compositions, with different manufacturers, were better than copper oxychloride. It was not the case for other extracts, that Mimosa and Camellia, that was selected in base of the suggestion of the experts. Also, among the authorized phytosanitaries tested, the potassium bicarbonate was very active against both botrytis isolates, and also lime sulfur was active against this pathogen, better than copper oxychloride. For the case of the cinnamon extract and for the case of the potassium bicarbonate, we observed that at the maximum dosage, they were fungicide. They also killed the botrytis. With the results, we asked for the cost of the products, because one of the limitations for the substitution, the phasing out of the copper, is the low price of these copper salts. And we found that the gluconic copper was really cheap. In comparison was cheap. Is what not the case for the other effective products. However, as gluconic copper has a content of copper, we decided to go for the field trials with the other two effective alternatives in the in vitro trials, using the minimum dose that is not fungicide for botrytis, but the price is more affordable by the growers of winter tomato crop, and they can, of course, they can afford this, because the number of application is not really very high in the greenhouse trials. Well, so we went to the greenhouse trials in two experiments, and they were arranged the last year in the heart of the Sea of Plastic, where is our facilities. And experiment one was formed by two greenhouses, and experiment two was arranged in one bigger greenhouse. The design of the trial was made thinking on avoiding the problems for the use of the different products, and we look for the inner part of each plot where the humidity was higher and where the concentration of plant was higher, just to look for the better conditions for the proliferation of the disease. In the experiment one, we used one tasty tomato. Both greenhouses are certified as organic for more than 20 years. And the second experiment was, we used a branched tomato type, and this was not certified as organic, but all the pesticide that we used in these greenhouses are allowed under organic agriculture. The conditions favorable to botrytis started at the end of November, and we had to make 5 spray application of the products in weeks 48, 50, and 2, 4, and 6 in this year. The products were applied the same day at the same week in the 3 greenhouses. And after the onset of the disease, the apparition of the first symptom in the plants, we started to record the incidence of botrytis plant by plant. We used groups of 18 or 36 plants, depending on the experimental plot, and we recorded the number of fruits, the number of petioles, the number of stems, and the number of leaves with signs of botrytis. Also, the number of dead plants that were appearing during the trial. The results for the experiment 1 didn't allow us to separate with statistic significance the results concerning the number of total incidents of botrytis per plot. But in the experiment 2, the best treatment or the treatment which reduced the incidence of botrytis per plot was the potassium bicarbonate, and the worst treatment was the cinnamon extract. I remember that both cinnamon extract and potassium bicarbonate were better than copper oxychloride in the in vitro tests. Concerning the number of plants killed by botrytis, in the experiment 1, the number of dead plants was very low. At the end of the trial, it was under 6% of dead plants. However, in the experiment 2, the number of dead plants of the treatment with the extract of cinnamon, the cinnamon extract was really high. This was due to the differences between the cultivars of the tomato cultivar, the tomato varieties. The branched tomato was very, very sensitive to the infection of the petioles, and this led to the infection of the stem and the death of the plant, where the treatments, the spray treatments, were not effective on stopping the proliferation of the fungi. The number of the plant was continuously increased. Here, there is a representation of the impact of the variety on the infection by botrytis. Not only the product, substitution product for copper, but also the variety was relevant in the trials. No? The tasty tomato was very sensitive for fruits, regardless the type of treatment used. However, the branched tomato was very sensitive for the petioles, and this is directly linked with the death of the plant, as I said before. As general remarks of our work, we could say that gray mold is in fact an endemic pathological problem in our cropping systems, because despite of the lack of rainy days in our winters, the humidity inside the greenhouse is too high during the nights, and in the days the humidity decrease, the temperature increase, and these conditions are very, very good for the proliferation of botrytis in the tomatoes. So therapy, application of a spraying product is necessary, and there are different alternatives to copper commercially available for growers. Among these products tested, the potassium hydrogen bicarbonate has shown results better than the copper in the field trials. And as a conclusion, we could say that at least there is one product available that can play a similar or better role than copper oxychloride to control botrytis in our conditions. This is only 1 year trial. We are starting the 2nd year trial, and we are going to change the location of the different treatments in the greenhouses, and we will get results, more results for the next year. I could say that it is feasible that more products could help to control this disease with copper, without copper, and also that the selection of the cultivar and the management of the climatic conditions, as well as the management of the crop, the pruning is quite important, can help also to reduce the number of application of copper or alternatives. But in the end, I could say that we can continue eating this European tomatoes in winter. I want to say thanks to my team, and now I think that I have finished the presentation, so thank you very much for your attention.